Hey, hello everybody. Welcome to another class. Let me do the checking here. See if the sound is fine. Hello, hello, testing. Hello. Hey, hello everybody. Okay, looks good. So in today's class, we will learn about basic types. It's very important that we understand this, and that is the reason I taught you about the binary system before. So let's do this. Let's go here and do C# data types. The first URL you'll find, Microsoft Build 2026. So this is the official documentation for .NET and C# about the types. And this is a very fundamental thing because do you remember I told you that a program use variable as ingredients. And a computer need to know what type of information is going to be stored, is going to be used, because under the hood, everything are binaries. So, as we can see, there is a list of the data types here. The first one is called bool, that stands for Boolean. So this is a special type that can only store two possible values, true or false. It's like a bit. If it's 0, it's false. If it's 1, it's true. So this is how we declare a Boolean variable. This is the name, identifier, and then how we assign a value, true or false. It's the only two options for a Boolean data type. Okay, each one of those you can go and see details. This is integer. Look, it's a byte. What I taught you in the previous class, that a byte is 8 bits. So if I ask you what is the maximum number we can represent with 8 bits, let's do the exercise here. What is showing here? Okay. Okay, let's go here. How you do this, and then how you do where is it? Reset curves. This is a common question that we get in certification, not interview. Code interview is very rare. Someone asks about this, but most in some certification back in the day. So if we have 1 byte, that 1 byte is divided in 8 bits. Let's try to make those bits here. I think it's not doing a good job here, but okay, let's try. We need 8. 1, 2, 3, 4, 5, 6, 7. So I can put one more here and then make the space more like evenly. Kind of that. I think is okay here. So do you remember from last class that we did something like the, oh, let me change it. This will be easy for me. So this will be 1. This will be 2. 4. Oh, let me do this, increase the size. So size will be XL. 8, 16, 32, 64, and 128. Do you remember this from the last class? So we have something like this. That means if we want to represent the number 128, will be 1, 0, 0, 0, 0, 0, 0 is 0. This is 128. 128. If we want to represent 130, it will be 128 plus 2. So it will be 1, 0, 0, 0, 0, 0, 1, and 0. So this will be 130. What is the maximum number if we turn everything on? Do you agree? And if you use a calculator, it will be 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. 255. In total, we can represent 256 numbers because there is the 0. 0 up to 255, we have 256 bits. So, if we get a certification question, what is the maximum number we can represent with 1 byte? That will be 255. There is a mathematical rule that the number of bits to power the number of bits tell us how many numbers we gonna represent. Because as we are doubling here, every time we double is a power of 2. If you like math, this is how you can, if you can memorize. But if you don't memorize, you can just do this. And if someone asks, oh, with 3 bits, 1, 2, 3, what is the maximum number? 7. Do you agree? With 4 bits, what is the maximum number? Well, 8, 12, 14, 15. So now you know how to calculate. That is the reason we learn about those binaries, because now you understand when we are here and we go to byte. Oh, we already had there. Oh no, this is boolean, byte. And then the byte is gonna show here. Look, there are other types. See, bytes 0 to 255. And this saying here, unsigned byte using 8 bits. Why this unsigned is important? Because there is this S byte, that this S byte is from minus 128 to plus 127. And why that? If we go back here, is because when we have a signed number, what that means? A number that can be positive or negative. Let me get this guy here. Is like this. One signed byte, this very first byte, is to represent the signal. If it's plus, I need this. If it's plus or if it's minus. And then, for example, plus will be 1, minus will be 0. So this byte is not used to represent the value, but just if it's positive or negative. So now we only do have 7 bits left to represent the numbers. And if you sum all this, you see that is 128. 127, of course. And you still have 0. So this is how we can represent positive and negative integers by using 1 bit, the far left one, to represent the signal. So if you want to represent 7, it's easy, 7 will be 0, 0, 0, 0, 0, like this. 0, 0, 0, 0 for each one of those, plus this one. And now 1, 1, 1. If it's positive, will be with 1 here. If it's -7, will be with a 0 here. Cool. So when we are working a problem, we need to understand over the scope of our variable. If I want to store ages, there is no negative age, so I will not pick up the type sbyte. I will pick up byte. There is another one, short. Do you see? Short is sign, so can be positive and negative, and use 16 bits. So that is why when we talk about data types, numeric data types, all of them, in most of the language, C#, Java, C, they all will have a range. The only language I know does not follow this is Python, because Python is crazy. Like, the range of your number will be how much memory do you have. But don't worry about that right now. Back in the days, when we were doing certification exam, we had to know all this, because they'd say, oh, a long, how many bits a long has? So you have to remember, 64. How many bits an unsigned int has? Oh, it's 32 bits. Those are huge numbers. Look at this. A long could be by minus this to plus this. So 100, million, billion, trillion, quadrillion, hectillion, pentillion. Okay, and there is those n. N here is for native. So basically, we'll see this a little bit later on, but .NET is platform independent. There's version that we're learning, the .NET Core. So we can run the same program in Linux, Windows, and Mac. However, every platform, every operational system, sometimes the version, each one of the native type can have a different range. So this, you have to be very careful when to use it. It's not common, only very rare situation. Most of the time, we will be using the not native ones. And I can tell you, 90% of the time, we're gonna just use int. But if you are doing interview, if you are working a problem, and oh, you need to store a number, you can ask, okay, what type of number? Is an age? Is a salary? Because we cannot put a salary as an integer. You're gonna learn that on. Or what is that number? Number of cells, number of minutes. So you have to have an idea to pick up the right type to accommodate the range that you need. So this is a very fundamental concept, and the only reason that I thought about binary system. Otherwise, in this point, it would be very hard for you to visualize this. And now you can see, oh, if my variable has only 8 bits in memory, and there is no signal bit, so everything can be on and off, represent a number. In a byte, I can only represent from 0 to 255. If there is a sign, then I am using 1 byte, everything else will be number, so this is the signal. And look how big those numbers go. Cool? So those are the integer types. Do you need to memorize this? No. Back in the days we had, now with AI, you just need to put, oh, I need to store age, I need to store this. And then, however, if the AI do hallucination, and you need to store negative integer, and they give you like a byte, your program will fail. As soon as you try to use a negative number, you're gonna get exception, your program will break, and if you don't know about this, you're gonna be like blind and lost. Cool? Okay, let's go back here. We already saw Boolean, byte, and sbyte, most of the other integer ones. So as you can see, this is all integer types. If we go back to this list, we see an interesting one here, like char. So char represents one symbol from the Unicode. So as a Unicode, we already have an idea about Unicode. It's a table that can map every signal symbol from any language that exists. So a char can only represent one char, one letter, one number, one symbol. Okay? And there is one catch when we are using char, that when we put a char constant, we need to use single quotes. Later on, when you learn about strings, we're going to use double quote. So this is how C# knows that you are defining a char and not a string with just one position. Cool? Let's go back here. And then we have short, U short. Those are other types that you're going to learn later on. But then there is object, delegate, and dynamic. And then there is this string that is very common as well. So string is a special type, is a complex type that we can store letters and numbers. It's alphanumeric. And we already saw one example. So do you see string is double quotes. Please don't get scared. You don't need to memorize all those things. Most of the time, we're going to be using int. Oh, sorry. Int or decimal or string. There are some cases where we need to store a fraction. We need to store a decimal part of the number. And there are these three guys, decimal, double, and float. Why do you have three types for decimal numbers? It is because depending on the application, could be more like a scientific application, could be a financial application. So each one of those types is more suitable for each case. For example, if we're using currency, money, we have to be careful to don't lose some precision when we do some operations. So this type is specific for that. If we're doing scientific calculation, so then we can maybe use float to double. Most of the case, we're going to be use decimal. So if you go and check those types, we can have an idea. Look, float use 4 bytes, double 8 bytes, decimal 16 bytes. And then we can see here what is the range. Is 1.5 multiplied by 10 minus 45. So those are huge numbers. And those numbers internally, they are represent a little bit different. There is some math behind to use like all that precision. Is that why I have three different types? Probably here is going to explain decimal type is appropriate when the required degree precision is determined by the number of digits on the right of the decimal point, such as number come with financial application. So what you need to get from this is every time you're going to store a salary, a price, something that is currency, define the type as decimal. If you're going to do something scientific, then you can decide between float and double. Okay? So now that we saw most of those cases, what I will do is our first experience with AI helping us our content. And this can be good, can be bad. It's a risk that I'm taking those classes because AI can hallucinate. What I will do is I will come here and I will create a new file that I will call 004 and then data types.cs. I will put this one using system public. For now, don't worry about this. Public class data types. Public start void. Don't worry about this as well. And that method run. And I can now start to use AI. I will start a new session just to make sure that everything is clear. Oh, it's already a new session. So I say, please, add to the current file examples how to use each one of the C# data types. Please explain, please add comments to explain how, to explain when we should pick them. For example, decimal for financial application, and how to use decimal constants. And there is one detail that I want to show you here. Let's see how good this work is going to be. Oh, I just figured out something. This Copilot, I don't have a subscription for it. The one that I have is for Windsurf. So maybe the response is going to be limited, but let's see how it goes. And then I can just copy this prompt and put in the Windsurf. Let's see. So as I put my prompt here, it's going to show this or allow, and is did some work, put all this content, and then I can accept. I will click keep, and then I will see the content. I have to review, and then it has code. Do you want me to build to see if there is an error? I say yes, build for me. But I could just click the button there, so I don't waste tokens with my agent doing this. So build successful, and if you want to run, I'm gonna say skip, because to run, do you remember what you're gonna do? We will come here to program. I'll put this, like, comment this line and say data types dot run. Now I can go there. I put a breakpoint right here, and then you can see. The goal is that, is explain as there is S byte, short, U short, int, unsigned int. But I can tell you this, most of the time we use like int. We're only going to use long when the number is too big. Look, this is int. Where is int? Here, int, and then long. Oh, my internet is bad again. Look at this. I'm getting this. And that's the reason that I was waiting to start the class later. So the integer, this is the range. So probably most of the thing you're going to store, this is possible. But if for some reason you need more space, instead of 32 bits, you need 64, you get long. Okay? It's just something that you know that if someday your program start to break, say overflow, the number is too big, you know, maybe I have to get type with a bigger range. There is example for everything. So do you see here there is a little f after this? It's just because if we don't put the f, this is seen as a double. So do you see the message? Literal of type double cannot be implicit converted to float. So whoever created C# said every time someone put a numeric constant and put a dot, that constant is a double. But my variable is float. So we need something to tell this, this is a float. So there is a little f that we put at the end. So now we don't get crazy if you see a number with a letter at the end. This is kind of silly, but it's just to tell, okay, this constant is not a double, it's a float. If it's a double, we don't need to put anything here because this constant is already a double. Fun enough, if it's a decimal, we don't put a D, but we put an M, because following the logic, if float is F, decimal should be D, but they put M. Some little thing that the language created that way, so we have to put the suffix M. You can Google to ask why. Maybe there is some good explanation. Okay. Here are Boolean types. We can have true or false. An example of chars that we have single quotes. And string that we saw before that we have double quotes. Cool. I will show you guys so you can understand this. So let's do this. I will save this. We can debug to see how it goes. I'm not happy because look what is going on. And the last time I had this, I lost half of the class. So let me do this. I will end the class here today. And in the next class, we'll learn about this interpolation here. But this basically is, we have this as a string. And when we open this bracket and close the bracket, that means whatever value we have in this variable will be replaced in this string. But I'll explain this later on. So the important thing of the today class, let's try to salvage it, is that we do have a list of predefined types in every language. And when we are creating our programs, we need to know what kind of value we're going to store. So then you can pick up the right data type. Cool. Okay, that is it. I hope my internet gets better next few days. So see you next class and God bless you. See you. Bye. Here. This is the range. So probably most of the thing you're going to store, this is possible. But if for some reason you need more space, instead of 32 bits, you need 60